Welcome guys in this new tutorial, and in this lecture we are going to talk about contactors. Contactors operate at the same principle that relays operate on. However, they are actuators for motors, so they are designed to handle large loads. So it contains a coil, and by energizing and de-energizing it, we can turn on and off a whole motor. So here's the coil on the left hand side, and on the right hand side we have three contacts in order to control a three-phase motor. So here we're energizing it and the contacts are latching, and here we are de-energizing and the contacts are delatching. And here, for example, the PLC is going to energize the relay is going to energize the contactor, and by that we can turn on a motor. And all of that is with a small signal of either 24 volt DC, or it could be 220 volt or 110 volt AC. Now, how do we choose these contactors? I mean, what are the rules required for us to know in order to choose a matching contactor with our motor or load in general? The first one is the AC one, which is used in three-phase heat loads. Say you are trying to heat a huge tank, so we use the three-phase heaters, and the way we connect and disconnect them is using a contactor. Now, if we use the AC3 type, this is the type that we usually use for motors and pumps. So before you buy a contactor, check what's your load and either buy AC1 or AC3 depending on your need. Second, we need to check what is the maximum current that these contacts can handle. When you're choosing this parameter, you need to take into account the inrush current that your motor is consuming. So if your inrush current is around 100 amps, you cannot take 90 or 80 amps rated contactors. Now the third type is the coil energizing type. As in relays, we had AC and DC, and it's the same thing for the contactors. Now the fourth parameter is the auxiliary contact. Remember, in that relay we were studying, we had an NC signal. The NC signal that was working as opposite to the NO signal. Now contactors may not come with this NC signal, and you can buy it additionally and attach it to your contactor so that you can have an NC signal. Now let's take an example. We have a motor which is rated at 1.5 kilowatts. Approximation of its power consumption is around 3.25 amps. And we're using a control circuit that is energizing the contactor at 24 volt DC. This motor is a three-phase, so the contactor is also a three-phase, and it is rated at 380 volt. Now, how do we choose the correct contactor for this motor? Since it's a motor, we need an AC3 type of contactor. And since we have the current, we need to check what is the inrush current for this motor. We will multiply this current with the worst case scenario, which is 6 volts. So the nominal current of the motor, which is 3.25 amperes, multiplied by 6 volts, which will yield 19.5 amperes. So the contactor's contacts should at least withstand around 20 amperes of current. Why are we taking the inrush current into account? Because the inrush current is, even though it lasts for a few seconds, we shouldn't take that risk, and we should take it into account while choosing the contactor here. So we will choose our contactor within that criteria.